Hello and welcome to today's core maths lesson. Our topic for today is plane geometry 1. If you remember, in our last lesson we started looking at plane geometry 1, and specifically I looked at angle properties of straight lines. Angle properties of straight lines in general in our last lesson. Now today I'm going to focus on the angle properties of parallel lines. The angle properties of parallel lines. Once again, I'm Clement Asiedu, Menlah, your facilitator for today. Now, what do I expect you to know by the end of the lesson? Now, by the end of the lesson, I expect you to be able to state the angle properties of parallel lines. You should be able to state it. In fact, you should be able to verbalize it, state it verbatim. And as we normally say, to be able to say it by heart. That is, to state it without referring to any book or reading from anywhere. It's very, very important, because in an exam condition, you are not supposed to refer to any book. So your ability to be able to memorize the properties is the first steps in helping you to be able to apply. So that will be the first thing I expect you to be able to do. Now the second thing I expect you to be able to do is to be able to use the properties to solve problems. You should be able to use the properties to solve problems. Now, for any lesson, you need what we call a relevant previous knowledge. You need a relevant previous. That is an understanding or a background that is going to help you to build on, to be able to understand the topic for the day. And so what are the things I expect you to be able to, or you are expected to know before you can build on from, you can actually understand the topic we are supposed to do today and be able to move on. Now, in this case, your what we call your RPK is going to be that you should be able to, we expect that you've gone through the angle properties of a straight line, what we did the previous time, and we expect that you have a very good understanding of it, and as it were, you could actually state the properties and apply them to solve questions. I remember before I ended that topic or that aspect of plane geometry 1, I actually said that the examples I gave and even the assignment I gave were supposed to be basic ones. Later, when we have gone through the properties, we will take time to look at very standard questions around them. So that is basically what I will be doing today also. The examples I'll be giving are basically the basic ones, just to explain the properties as they come up. And when, as I said, when we've been able to go through all of them, then we'll take maybe a lesson or two to actually look at standard questions. If possible, take past questions and look at them. Take very good questions from very good books, pamphlets or whatever, and then be able to go through them so that your understanding of the topic will be very solid and will be in a good position to face any exam in that area, or have relevant enough knowledge even to be able to help your colleagues. Now, let me get into the lesson for today. Lesson, as usual, we'll pick it up from the background. So remember, in our last statement, we went through the properties, the angle properties of a straight line. Namely, for example, you need to understand that the sum of adjacent angles in a right angle is 90 degrees, and that the sum of angles on a straight, adjacent angles on a straight line is 180. That we expect that you know that the sum of angles around a point is 360 degrees, and then finally that vertically opposite angles are equal. those are the four areas or the four properties we went through the last time we met. Now today, as I said, I'm going to specifically look at angle properties of parallel lines. Angle properties of parallel lines. So basically, normally you will start from what are parallel lines? What are parallel lines? And from basic school and JHS, I want to believe that you have an idea of what parallel lines are. Now, what are parallel lines? Basically, when we're in basic school, we normally say parallel lines are two or more lines that do not meet. Yes, at this level, it's a good place to start from. So we say that these are parallel lines are two or more lines. And here I'll just restrict myself to just two of them. Two lines that do not meet. Now, let me emphasize this. Now, in mathematics, we normally do not just assume. So, if you came across, for example, these two lines, now, how would you know, or how can you be categorical that these two lines are parallel lines? You are not going to say they are parallel lines because they look like they are not going to meet. But in mathematics, there is an indication that is used to actually indicate. There are signs that is used to actually indicate that the lines are parallel lines, so that you don't just assume. So for you to actually accept, or for you to actually be categorical that, for example, these two lines are parallel, you must see these arrows. For example, two arrows directed in a common direction. See something like that. That is what actually proves, or that is actually mathematically emphasize the fact that these two lines are parallel, not just because they look like they are not going to meet. So that I can actually, just by the way, I can actually put up something of this nature. And then once I put these two indications there, you can still accept that these two lines are parallel lines. You should expect to be. For these two lines, it seems, if you look at it from the board, it seems as they go, they are likely to probably meet somewhere. And so, if you saw this, you could easily discount it as not parallel lines. But because of the two arrows I have put there, you are expected to accept that they are parallel lines. So that is one important thing I want you to take note. Now, another thing we must understand is that for two parallel lines, or anytime you have parallel lines, any line that cuts across the parallel lines has a special name. Any line that cuts across parallel lines is referred to as transversal. Any line that cuts across two or more lines that are supposed to be parallel is referred to as a transversal. And once you have a transversal cutting across two parallel lines, it's going to throw up 8 different angles. And so if you look at the angle, the diagram that I have, for example, this angle, which is A, this one I'll call B, this one, let me take off the arrow from here and probably put it here, it's still the same. This one that I'll call C, and this one that I'll call D. Then this one that I'll call E, then this one that I'll call F, this one that I'll call G, and this one that I'm going to call H. So with these two parallel lines, with the transversal, 8 angles are thrown up. Now, I'm going to look at them, the angle properties around these angles. And basically I'm going to look at under angle properties of parallel lines. I'm basically going to look at three basic properties, three basic angle properties. And please, I want you to follow me carefully so that you can actually understand. Now remember, before I get into the actual properties, remember that the other properties we learned under angle properties of a straight line still apply here. In a typical example, you are supposed to remember they still apply, those angles, because what you have here, for example, if I label this PQ, that's the line PQ, and I label this ST. Remember, the line PQ is a straight line, and so the angles around here, this point, are actually they can follow those angle properties we learned under straight line. So for example, you will notice that angle A and C are vertically opposite, and we expect them to be equal. B and D are also vertically opposite. A and B are angles, adjacent angles on the line. So those properties still hold here. So please don't just isolate them. In a typical example, you are supposed to bring all of them on board, and that is why they are relevant previous knowledge. That's why they are basic knowledge you need to build on. You cannot take angle properties of parallel lines in isolation. You will have to still bring in those other properties. Now let me get into those three basic properties concerning parallel lines I was talking about. Now, number one, when you are dealing with parallel lines, one of the angle properties you are going to deal with is what we call corresponding angles. Corresponding angles. So corresponding angles. So that is the first property that I'm going to discuss. One of the properties you are supposed to. Now, I'm going to give you some indicators, and I'm going to give you three of them. Now, if you can get any two angles that, as it were, follows all those three indicators, then those two angles will correspond. Now, the first indication that I'm going to give you is that the two angles must be at different points. The two angles must be at different points. Now, what do I mean by that? What I mean by that is that if you look at the setup that I have here, there are 2 points. That is this point, for example, and this point. Now I'm saying that for two angles that are going to correspond, the two angles must be at different points. So in effect, what I'm saying is that you cannot have two angles that are around the same point forming corresponding angles. If two angles are around the same point, they cannot form corresponding, or they cannot correspond. So for example, angle A and B cannot correspond. B and C, A and D, or the angles, because they are all A, B, C, D. All those four angles are around the same point. So no two angles from those two angles I have in that area can form corresponding angles. In a similar manner, angle EFGH, they are also around the same point. So no two of them can form corresponding angles. So that is your first condition when it comes to corresponding angles. Take note. Now the second indicator I'm also going to give you is that the two angles must be on different sides of the transversal. The two angles must be on different sides of the transversal. The two angles must be on different sides of the transversal. Now, what does that mean? Now, what that means is that we know the transversal. This is the transversal. In my setup, this is my transversal. And I'm saying that for two angles that are going to form corresponding angles, in fact, both of them, so that if I have to, okay, oh sorry, on the same side, sorry, okay, sorry about that. I kept saying different, but it should be same. So what I'm saying is that the two angles must be on the same side of the transversal. Now, for example, if I take my setup, this is my transversal. There are two sides of my transversal, but I have this will be my right hand side of my transversal, and this is my left hand side. On the left hand side, I have angles like A, D, E, and G. On the right hand side of the transversal, I have angles like B, C, F, and H. Right. So I'm saying that for two angles that are going to form, corresponding angles, the angles must be on the same side. So for example, angle ADEG, two of them can form because they are on the same side. B, C, F, and H, two of them can form because they are on the same side. And then finally, the last indicator, as I said, the last indicator is that for the two angles, one must be inside and the other outside the two parallel lines. So one must be inside and the other outside the two parallel lines. So that's my last. So what I'm saying is that if I take my parallel lines PQ and then ST, I'm saying that for those two angles that are going to correspond, one of them must be inside. When I talk about inside, I'm talking about within here. And those angles, for now, those angles that are inside are C, D, F, and E. And then those that are outside are A, B, G, and H. Now, what I'm saying is that for two angles to correspond, they must follow all these three conditions. So if you can find me any two angles that satisfy all these three conditions, I can emphatically tell you that those two angles correspond, or those two angles form what we call corresponding angles. So let's do that exercise. Let's do that exercise. You can let me give you time to go through so that you can probably identify the ones that correspond. I'm sure you were able to do that. But for the sake of time, let me pick it up from here. Now, for example, so you will notice that angles like A and E will correspond. Why? Because angle A and E satisfy all these three conditions. In the first place, look at it, the two angles are at different points. For example, A is at this point and E is also at this different point. So they are at two different points. So that first condition is satisfied. The second condition is that the two angles must be on the same side of the transversal. This is my transversal. A and E, both of them are on the left hand side of my transversal. So the second condition is also satisfied. The last one is that one must be inside and the other outside the two parallel lines. So you notice that in this case, E is inside and A is outside. So it means that A and E satisfies all these three conditions. And so I can emphatically tell you that A and E correspond. So will also be D and G, and then also B and F, and then C and H. You will notice that they all satisfy the three conditions in that manner. Then, having been able to identify corresponding angles, let's now come out with the property. Let's now come out with the property. So from the diagram, now the property says that corresponding angles are equal. Corresponding angles are equal. And so if A and E, D and G, C and H, and B and F correspond, then from my diagram I can easily say that therefore A equals E, B or A equals E, B equals F, C equals H, and D equals G. D equals G. Now, in most books, they will tell you that corresponding go, yeah. So corresponding angles are equal. So therefore, all these angles should be equal. Now, if you want a shortcut, you are always going to see that the corresponding angles follows a certain capital F. It follows a certain capital F. So if you are able to, from the angle properties, from the diagram, if you are able to carve out an F, something in the form of an F, maybe of that nature, or this nature, or that nature, or in that form, anytime you are able to create a certain F, the angles here, the one here will correspond, the one here will also correspond, the one here, the ones here will also correspond, these ones will also correspond. So in terms of, and you notice that they follow all those three. And what I mean is that from here, for example, if I'm able to create a certain F from these two parallel lines this way, then the angle here and the angle here will correspond. If I pick this F, the angle here and the angle here will correspond. If I pick an F which is turned upside down this way, the angle here and this one will correspond. If I pick this one, the angle here and the angle there will also correspond. So that is basically about the corresponding angles. Now let me go to the second one for the sake of time. Let me go to the second one. Now the second one, I'm looking at what we call, so in terms of second property, I will be using, I'm going to what I call alternate angles. So one of the properties around parallel lines that you also need to take note is what we call alternate angles. We have just finished looking at corresponding angles. We are now looking at alternate angles. Now, again, I'm going to give you three indicators. I'm going to use the one I've already written, but I'll be changing a few things. Now, the first one is similar to what we already have there. So we are saying that for any two angles to alternate, the two angles must be at different points. For any two angles to alternate, the two angles must be at different points. So the first condition still holds. Now what about the second one? The second one will change. Now the two angles must be on this time on different sides. the two angles must be on different sides of the transversal. The two angles must be on different sides of the transversal. And then the C will also change. In this case, the condition will be both must be inside or outside the parallel lines. Right. So that is what we have. So we are saying that, so for two angles to alternate from the setup we have, they must satisfy all. And please, the emphasis is on all. Even if you satisfy two of them and you are not able to satisfy the other one, you're still not done. For us to be able to say that the two angles alternate or correspond, they must satisfy all of them. All of them. So both of them must be at different points, and then the two angles must be on different sides, either in this case on the left hand side or on the right hand side, and then both must be inside. That is, either both of them are within the parallel lines or both of them are outside the parallel lines. So in that case, we go through. So again, let me give you some 30 seconds to go through and be able to identify the alternate ones amongst them. The alternate ones among them. Right. So let me take it out from here. So if you look at it properly, critically, which of them? Angles like C and E alternate because they satisfy all the three conditions. One is that the two angles are different points, and then the two angles are on different sides, and both of them are inside. So they satisfy all the 3 points, so they alternate. And then D and F also. D and F also. That is the inside one. The outside ones, you have A and H, and then B and G. Now, so those are alternate angles. Now, what is the property here when it comes to alternate angles? The property is that alternate angles, just like the corresponding angles, alternate angles are equal. Alternate angles are also equal. So in that case, therefore, it will mean that from our diagram, C is equal to E, D is equal to F, that is C and E, D and F, A is equal to H, and B is equal to G. So those ones will be what we call the alternate angles, and they are equal. Please take note of that. Please take note of that. So those are the alternate angles. Now, finally, I want to look at the last property under this particular topic. I said there are 3 of them: corresponding, alternate, and then the last one, which we call, co-interior. We have what we call co-interior angles, or some books refer to it as interior. Some books refer to as interior opposite angles. So it's either called co-interior angles or interior opposite angles. So again, we'll quickly go through. And as usual, I'm going to give you 3 indicators. And again, the A as I have it satisfies, will still hold. For 2 angles to be co-interior, the two angles must be at different points. So we'll still go along with the first condition. Then the second condition, the two angles must be on, this time it should be on the same side. On the same, okay, on the same side. The two angles must be on the same side. And then finally, both must be inside. Both must be inside. Both must be inside the parallel lines. So I'm saying that if you can find any two angles that satisfy these two conditions, those two angles will be co-interior, or you can call them co-interior angles. So once again, let me give you the opportunity to go through and then be able to identify them. Okay, so which ones are co-interior? In this case, you have E and D, or D and E, and then C and F. They will be co-interior angles because, for example, D and E, they satisfy all the conditions. One is that they are different points. Two is that they are on the same side of the transversal, and then three is that both of them are inside. In a similar manner, if you take C and F, both of they are different points. They are on the same side, and then both of them are inside. And so we are saying that D and E are co-interior angles, and then C and F are also co-interior angles. Now, what is the property around co-interior angles? Now, remember, and I must emphasize here, co-interior angles, unlike corresponding angles and alternate angles, are not equal. Please take note of that. Co-interior angles, unlike corresponding or alternate angles, they are not equal. But we say that co-interior angles are supplementary, or simply that co-interior angles sum up to 180 degrees. So that is the property around co-interior angles. Let me state it for you to put it down. So co-interior angles are supplementary. That is, they sum up to 180 degrees. And so from our setup, we are going to have, it means that C plus F will give us 180 degrees, and D plus E will also give us 180 degrees. So in short, those are the three basic properties that we are supposed to be familiar with concerning parallel lines. So these three properties are what we refer to as angle properties of parallel lines. Please take note to imbibe it, and then know it very well. You should be able to, as I said, you should be able to state them. Fortunately, these ones are very simple. State them and be able to apply them to solve questions. I didn't get much into the shortcuts for alternate and then the co-interior. But in short, for the alternate, if you are looking for shortcut, normally you have to be able to create a certain Z in whatever form. It could be line, a certain Z. Once you can create a certain Z from what do you call it? Your diagram, where these ones are the parallel lines. These are ones are the parallel lines. then the angles at the corner here, the angles at the corners will always alternate. So that's how you come out with alternate angles. The angles at the corners here. So if you are looking for shortcuts for the alternate angles, that is it. In the case of corresponding angles, you should be able to come out with a certain C. A certain C in some form. For example, it could be in this form, it could be in that form, it could be in this form, and it could be in that form. But you are getting something like a certain box or a C. Ones where these ones are the alternates, what do you call it there? The parallel lines. In that case, the angles here will always correspond. Let me quickly look at that for you. So, for example, for the alternate, once you can create this Z, the angle here and the angle here and the angle here will alternate. For the corresponding, these ones, once you can create a certain C like that, those ones will alternate. So those are the three properties. Before I end, let me pick maybe just one or two examples just to round it up. And as I said, those are just examples to explain the properties. Later, we'll take time to look at standard questions that lend themselves to some of these properties. So quickly, let me now erase this side, and then so for example, if okay, so let's just work with these two. So with these indications, I'm saying that so this time I have three parallel lines, and then I have my transversal. So I want to know X and Y. Now, if you have followed what I just did, you straight away notice that angle X alternates with the angle 95. And we have said that alternate angles are equal. So straight away we can say that X is equal to 95 degrees. And then again, you also notice that angle Y corresponds with angle 95. And so straight away we can also say that Y is also equal to 95 degrees. So that if, for example, you wanted to find angle Z, for example, again, you will notice that Z and 95 are co-interior if you go by the conditions I have given you. And so we can simply say that Z plus 90, let me put it here so that it will be clearer for us. So that we can see that Z plus 95 is equal to 180. Remember, corresponding co-interior angles are not equal, but they sum up to 180. So in that case, from that equation, Z will be equal to 180 degrees minus 95. Z is equal to 85 degrees. So that is one simple example just to explain the three concepts we have just gone through. So just to summarize or to round up, let me give you a simple assignment, something small for you to feed on, and hopefully when we meet, when we have had an opportunity to go through the properties, as I said, we'll create an opportunity where we'll pick a lesson or two to take examples and look at the properties in its entirety with standard questions. So for an assignment, we shall have okay, so for your assignment, find the letters P, Q, and R in that diagram. Hopefully, when we finish with the property, we'll take time and look at a lot more standard and typical questions. So, thank you very much. And in short, we have gone through the three properties that falls under angle properties of parallel lines, namely corresponding angles, alternate angles, and co-interior angles. Thank you very much. Once again, I'm Clement Asiedu, Menlah, your facilitator for the lesson. You can always contact me, as I always say, on 0244 591 345, or you can email me. It's also my WhatsApp line, so you can send me a WhatsApp, or you can email me on Clement Asiedu Menlah. Clement Asiedu Menlah, that's my name, at gmail.com. So you can always contact me with all your concerns and questions on these two contacts. Thank you very much.